Hello, Mr. Eric, Mr. Ryan, are you right?
Yeah.
Okay, so we're given a sentence with some words. Eric, and Happy, Ryan, and okay. Okay, so we are given a sentence of words separated by white space. The first one is Eric. The second one is Ryan. So there could be many Eric and could be many Ryan in a string. So the question is that what's the shortest distance between any Eric to any Ryan in this string?
Two,
I mean,
two.
two, yeah? Yeah. Okay, the shortest distance means the number of words between those. Right? So look, there are two words. Yeah? Two words between Eric and Ryan. That's the closest. Alright?
Eric,
How about if I add
Ryan, and okay.
If I add that Ryan here, what's the shortest distance between Eric and Ryan?
0.
Yeah, 0. To repeat, we are given a string of words separated by white space, and we are given two words. We want to find out the shortest distance. Shortest distance as defined as the number of words between any word 1 on any word 2. If there's no Eric or if there's no Ryan in the sentence, we return -1. Okay? Yeah, first of all, split. Yeah, that's very good. So first of all, we split the string. Yeah. So array equals s dot split. So we split the string into array of words. Well, how do we solve this? I just need a general idea. It doesn't have to be concrete. Enumerate. Yeah, we're going to enumerate and how? How do we do it?
Index.
Yes, index of the words. So how do we deal with the index?
I visually see the word.
Yeah.
Scanning.
Yeah, scanning. Yeah.
For the shortest distance. And
Ryan.
That and that.
Okay, and then what do you
And
do with
this is
that?
the closest to that. So yeah, you just collect this Eric.
You
and
collect
find
one index, yes? The
Yeah,
place
and
is,
then find
the
the
other
other one.
and then what do you do? Suppose, okay, so the index for Ryan, yeah? Index for Ryan is 0, 5, right? And the index for Eric is 1, 2, right?
You find if there's like you just visually see this. Oh yeah, 0.
Yeah, still, no, yeah, I understand, but still, not visually, yeah. Come.
But if it's like this size, which is this size, this is 2 and this is also 2, which is perfect because you just find the smallest one, but this one is sorted, so that's good.
Wait, yes?
This one is the smallest,
Uh-huh.
and this is also the smallest, and then you can just do like this is the biggest, and then this is the biggest. This is remain 3, and the smallest 1.
These could be many numbers instead of 2. So it could be many numbers, like 0, 2, 3, 4, 5, okay, for the first one. And the second one could be many cases, 1, 2, 6, 8, okay.
Then you just do the smallest ones. See?
Smallest one.
Yeah. See?
You sure? But look, if the smallest one could be like that. So clearly, this is 4 difference, but here, it's 3. It's shorter with the maximum. Do you see my point?
Yeah.
So it doesn't work, right?
Yes.
We have these two arrays, sorted array, A and B, sorted array. How would you find the smallest distance between any two numbers in the array? Okay, that's the question, yeah? What's the method to ask computer to try?
Enumerate. Brute force.
Yeah, brute force. We can brute force, yeah? Alright? We can brute force the numbers, but this does not use the fact that they are both sorted, right? Yeah? And in fact, if we brute forcing it, the time complexity will be O(n squared, right? Yeah, O(n squared. Okay, because we have to find the pairs, right? Alright? This is too slow, okay? This is the key thing today.
Yes.
This method could work if the size of the string is small, then possibly that's okay. We collect the index for those words, and then we'll try to brute force any number from Ryan, any number from Eric, and we'll try to see which two numbers have the shortest distance, right? That's very slow. Another way, first of all, obviously we need to split the sentences to words. We'll go through the words, yeah? If it's any of these words, right? Then we check if it is the same as the previous one. if it's the same as the last recorded one. Okay? If it's not, then that's the shortest distance we calculated. If it is, we just update it. I'm last, okay? At the beginning, I set it to none. The index here is 0. This word is one of the Eric and Ryan, right? It's in here. We haven't met any of these, so I just set it to last equals to 0, right? Because it means that last position, the last place that any of these words appear is at index 0, okay? Okay, Eric, here.
Mm-hmm.
Now, I got this is also in one of these words. So I check if it's the same as the last one. It's not, right? It's not, then answer will be the minimum of these. The distance will be 0. The last I need to set it to 1, right? Because this is one of the words we just met. Eric is equal to the last. So I don't check the answer anymore. Instead, I update it to 2. To sum up, we just go through the list of words and then every time we update the last index if we meet one of these words, right? And if this word, current word, is not the same as last word, we calculate distance and remember the smallest. Mean. Okay, mean distance. S, first of all, ARR equals S dot split. We split the sentence. At the beginning, answer equals infinity. And the last, at the beginning, we set it to none. This is the last place that one of these words appear, W1 or W2. For the index and the current, in enumerate. What's enumerate?
Sorting into kind of groups.
Yeah. With what? What's this?
Index.
What's this? IX enumerate these. So what's I?
Index.
0, 1, 2, 3, 4. What's the value of X?
1, 2, yeah.
Yeah, that's what it means. So current is the words, right? The words. Look. Remember that Eric Ryan thing, yeah? Eric Ryan thing. This is the list of words we converted, yeah? If current is in W1 or W2, right? If it's in one of these words, if first of all last is not none, right? Because at the beginning it's none, and if the current is not equals to that stores the index. It's not equal to array last, right? Then we calculate the distance. Answer equals the minimum of answer. Current index is I. The previous index is last. The number of words between them is -1. Alright? The number of index 2. This is Eric. This is Ryan. This index is 2. This index is 3. How many words between Eric and Ryan here?
0.
Okay, so how do we get 0? This is 2, index 2, this is index 3. How do we get 0?
3 minus 2.
That's 1.
Minus 1.
Yeah, we need to -1 here. Look, here's what it means. Okay, and then look, after every time it's in the current, right? So we need to set the last equals I, right? And then return answer if answer is not equal to infinity, else -1, right? If it's equal to infinity, we don't find anything here. We don't find one of these words, so it's infinity. Okay? Time complexity, ON, right? Space complexity. We are using the array, so that space complexity will be ON as well. Okay? So to sum up, what have you learned today? What's the problem and what have you learned? And that's it.
They learned
What's the problem and what have you
the
learned?
minimum distance of 2 words in a sentence. Well, not really a sentence. Yeah.
Sorry?
The distance between 2 words in this kind of long sentence thingy, you know what you call it. By using
How do we solve
split,
it?
enumerate,
No.
brute force.
Brute force is ON square, but what's this approach?
So we get our thingy, you know, and we check every word, and then check the second one and check if it's the same as the last one.
Yeah, you're getting there, yes, and?
And if it is, you just update it.
Yeah.
If it isn't, you go to the next one.
slightly incorrect here. So we always remember the last, update the last one. And if it's only different, right? If it's the current word is different than the last one, we calculate the distance, alright? If it's the same, there's no point to calculate, alright?
Yeah.
Do you get it?
Yeah.
Okay. That's it for today. Bye bye.
Bye bye.
Bye bye.
Bye bye.